Hello guys, my name's Alex. In this tutorial we'll be making a racetrack with a spline, but not in the traditional way you've seen in other tutorials where the object or cars in this case follow the spline exactly, fixed on it. We'll be making the cars follow the spline dynamically. So not attached to it, but definitely following the spline. So currently my cars are just going willy-nilly into the city. That is not what I want. I want my cars to follow the road. We'll go to blueprint class, we'll go to actor, BP, spline, track, nice. And we'll open this. Here we'll add a spline component, and that's about it. Now we'll need to add it in our scene, and we'll need to expand this spline across our racetrack. Make sure it's pointed in the direction of your desired way, and you need to go to transform, and if you want to expand your spline, you hold Alt, like this, and then we add another one. I'll speed up here. Now that's done. If you like to combine your splines so it makes a perfect loop, you select the spline, make sure it's selected here and in the outliner, scroll down, and we have here a closed loop, and it will automatically link the end to the start. Now we'll need a way to tell our character about the spline. We can go in our character and we can either do it the quicker way, hacky way, whatever you want to call it. We can get all actors of class. We can search here the BP spline that we created earlier. You can get a copy and then you can make a reference to this. And we can call it spline racetrack. You can do this, but it's a hacky way and it's costly because it looks through all your actors in your level to find this specific one. We can do it a different way where we can still keep this variable. We can do a cast just as a check to ensure that it's found and connected. Make sure you connect it here as well. It's telling us that it's the same thing, so we don't need the cast, but we'll do it anyway as a verification. Of course, we can still use is valid. Then this variable, we need to click on the eye to make it public, so we can edit it in the editor. And now if we select our character or object, we'll have it right here. Spline racetrack, that's the variable we created earlier, and from here we can add our spline track, which is this one right here on the map, and we'll do it for the other character as well. Now that's it, so our cars are connected to the spline, so they know about it, they know what it is and where it's going. We'll go back to our character. In my case, my car is moving forward automatically. No, I'm not using a vehicle component, nor an AI. I made them straight out of code because I wanted them to be more controllable. I'm not that great with AI, so this works better for me. And all I'm doing is adding forward movement on the tick. Now let's get to the coding part. We'll get our spline track, or you can search it. We'll get the spline from inside the actor, and here we'll look for find tangent. Yes, we'll get our actor's location and connect it right here. Make sure you set your coordinates to world, not local, otherwise you will have a lot of issues. We'll normalize, can leave it with default. Now we'll add this to our location. We need to drag from the spline and find location closest to world, and we'll connect this add. And let's not forget, we'll need to set this to world as well. Now, to make this different than other tutorials, we'll use find LookAtRotation. This find closest location will be the target, and our start will be our character's or object's location. Here we'll make a delta rotator. We'll get our actor's rotation. We'll split this rotator so we get values for each axis. And here we'll add actor local rotation. We'll split it again. And we'll connect the z-axis to the z-axis of the actor location. Now, for debugging purposes, we can also add a sphere trace, and we'll connect these two to start and end, so we can see the precise location where we are along the spline, and we'll set it to debug for 1 frame. Now, we'll need a way to call this. You could use an event tick, though that's quite expensive if you have many actors that are doing this. So instead, in my case, I have right here a timer, and then you write here the name of your custom event. I have this one's running at 0.009, which it's probably still cheaper than Eventic, which runs once every frame. And we can go for something like 0.015 or 0.02 or even 0.1 if you don't need it to be super updated. We'll test it, we'll see how it is. And now that we have this in place, we can make a custom event. Call this earring. Alright, so that's the whole thing. Let's compile. No errors, all good. Very nice. And let's see if this works. Oh my, what are our cars doing? They are stuck on the spline and we are not having our debug. Oh, I didn't set the radius here. I will set the radius to like 100 and let's try again. Well, we can see the radius. It's right there in front of the cars. But our cars are going crazy. Oh my, why? How do we fix that? Well, we'll fix it by, we'll go here between the normalize and the add, and we'll add the multiplication. Multiply, and we'll connect this here, and then we'll convert this to a float. Right click on the dot and float, and we'll set this to like 1400. Yeah. Now let's see how it looks. And I'll show you why we did this. Look at that. You see our debug right there? It's following the spline but ahead, which makes our cars lag behind, which is exactly what we need. This way, we are getting a location on our spline, we are moving it ahead, then we find the location on the spline that we currently have. We set our character to look at that location, and we change our character's rotation with this function based on where we are looking. Let's make this a bit bigger, where it's more visible. And as you can see, our cars are following along the spline perfectly. The nice thing about this is, in my case, since I'm making a racing game, I can go to friction, and I can set the ground friction to 0, which will make my cars drift at a high speed. And here's the thing, because now we are not actually attached with the spline, the car won't be following it 100%. So when it's going like really fast, which we'll see in a moment here, it will have trouble with corners, which look at that, that was a drift. And again, oh god, we're going through the buildings. And we just bumped into the other car. So you see how my car is drifting. Now if I go back to my friction and I set it to 8, which I believe is the default setting, now the car will be a lot more grounded. So even if we catch up speed, the car won't suddenly get off the road anymore. It will take sharp turns, it will follow the spline accordingly. Though still at a high speed, it can still fail to follow the spline. Now, as an additional point, let's say that you don't want your object to follow so tightly. And this is also why it's good that we are going for a LookAtRotation kind of orientation instead of following the spline precisely. We can get this, we'll get a map clamp and we'll connect it here instead. And what this does, you can tell it how much turning power you want your object to have when it's following the spline. And it will keep trying to adjust when you give it a small value so that it matches the rotation. So let's say we can put here -20 and here 20, then here it will be -1 and 1. So we've put a clamping on it. Now when we start, our car, you see, it's having a hard time turning around the corner. Now this is affected by how many times you are calling this function. My timer, it's calling it 0.1 times per second. Now if we set this way lower to 0.1 instead, it will have a much easier time taking that turn. And we're speeding up, see? So it's still having trouble, even though now we are 8 friction, still having trouble taking the turn, which causes again a drift. Because we have the clamping and we don't let the car fully follow the spline. Oh god, oh look at that, we came back in place. Very nice, right? And well, that's about it. This is how we make a spline without attaching our characters to it. Characters are completely free to move, to do all kind of janky stuff, which I guess in games that's what we love. If this was helpful, subscribe and drop a like.